Welcome back. I know you have been anxiously awaiting 5.2, so here we go. I won't extend your misery any longer. 5.2 deals with the uniform distribution. The uniform distribution is a continuous probability distribution, so we're still looking at that rectangle. It is concerned with events that are equally likely to occur. That's important. It has a uniform distribution if its values are spread evenly over the range of possibilities. The graph of a uniform distribution results in a rectangular shape, so we're still dealing with our rectangles. Now here's the notation we've got to talk about so we can talk to each other. This is still our big X. This is still our random variable from chapter 4. I'm still going to call it big X because they can look very similar, big X and little x. I'm still going to call it big X. The U stands for a uniform. Before we had a B right there, and it was for binomial. This time we're using U for uniform. The A is the minimum value. The B is the maximum value. So here we go with some formulas. We get the uniform distribution function or probability density function. That's very similar to what we just took a look at. The theoretical mean, that's the expected value. And the theoretical standard deviation. We're still using baby sigma for that. Here's what you have to really watch for when you deal with uniform distributions. You have to watch out for your inequality signs. These can make or break you. These are how you know whether your endpoints are included or excluded. If they are included, that means you are going to see a less than or equal to or a greater than or equal to. If they are excluded, that means you will see strictly less than or strictly greater than. So you have to make sure you pay attention to these. They are going to be crucial for your success with these guys. So here we go. We are going to look at finding the sample mean and the sample standard deviation for the data in the chart. When we look at the sample mean and the sample standard deviation, I just want to remind you quickly of a notation thing. When you look at sample mean, remember the sample mean is X bar. And our sample standard deviation is S.
Oh my goodness.
Our population mean was mu. And our population standard deviation was little sigma. Just a reminder. I'm not going to set up StatCrunch here, but you do have the steps you need. You can copy and paste this table into StatCrunch, but when I did it, it ended up looking exactly like this. So you may want to copy and paste it one column at a time so that you end up with all of your data in one long column. When you calculate these, you should get a sample mean of 11.64 and a sample standard deviation of 6.10. If you try to calculate these and something goes wrong, you're not getting those values, let me know, and I will absolutely help you take care of that. So we are still we're still using that chart up above. It is a table with data showing the smiling times in seconds for 55 8-week-old babies. So assuming the smiling times follow a uniform distribution, this tells us the shape of our graph. Between 0 and 23 seconds, inclusive. So that means our interval includes 0 and includes 23 seconds. This means that any smiling time from 0 to and including 23 seconds is equally likely. So everything has the same chance to occur. The histogram that can be constructed from the sample is an empirical distribution that closely matches the theoretical uniform distribution. So here we go. Here's our big X. Big X is the length in seconds of an 8-week-old baby's smile. So we want to take a look at the uniform distribution function for X between 0 and 23. So if we use the notation from the previous page, that means that we have our random variable X, the uniform distribution from 0 to 23. To find our function, f of x is 1 over b minus a for a less than or equal to x, less than or equal to b. So I'm going to fill in my pieces. So I know my b value is 23. My a is 0. So there's my pieces filled in. So that means f of x is 1 over 23. So I have a horizontal line at y equals 1 over 23 for 0 less than or equal to x less than or equal to 23. Let's go take a look at two things. Let's take a look at the theoretical mean. Remember that was mu is a plus b over 2. I'm going to fill in my pieces. A was 0, B was 23. (23) divided by 2 gives me 11.5. And remember, our table is dealing with seconds. So our average time would be 11.5 seconds. And then we have, hold on, the theoretical standard deviation is this super fancy formula that makes me feel very smart when I know how to use it. So I'm going to go plug in my pieces. I'm going to go get my B and my A. And because I love you, I have already plugged this into the calculator. I'm going to come out with a standard deviation of 6.63 seconds. We will stop there for now, and I'll catch the rest in part 2.